Perfect. So I've got this, whoops, there we go. We're starting a new chapter today, Patterns in Scatter Plots and Correlation, chapter 3. And there's going to be a lot of notes today. So if you don't write quick, you might want to just listen, and then you can always go back and watch this video when you've got time, you know, and pause it and write down what you want to write down, you know, as far as your own is concerned. So this is basically an introduction to a new topic. And there we go, I'm just getting things quiet. So if you want to answer, hopefully you do want to answer, you'll hit spacebar. So let's start with what a scatter plot looks like. So what you have in a scatter plot is basically your data isn't a single number now, it's actually a pair of numbers, both numerical. So an example of a scatter plot might be that you measured the weight of lots of baby animals. So you're in a zoo or a farm and you've got tons of baby animals, and this is their month, how old they are, right? So this is their age in months. And you measure that against their weight. And let's say the weight went 2, 4, 6, 8, 10, 12, 14, right? And we'll have the weight in pounds. So one of these baby animals, 1 month old, weighed 4 pounds. Another one only weighed 1.2 pounds. And each of these dots that I'm plotting would represent one animal. And it's just like coordinates. So for instance, let's put a dot in. This dot here that I'm just putting in, I'll make it green so it's noticeable. This dot here represents a 3-month-old baby animal, and that particular animal weighed 6 pounds. Can you see that you could have more than one animal that's 3 months old and they won't all weigh exactly the weight? Wouldn't you have a fat 3-month-old one and a skinny 3-month-old one? Think of babies, right? Things like that, right? Not every 6-month-old baby is the same weight, right? Not every 6-month-old rabbit is the same weight either, right? So a scatter plot is basically a way of visually representing a pair of data. So for instance, this one here, the one I just wrote down a few seconds ago, 3, 6, let's just look at coordinate. That represents one rabbit, and it represents the fact that that rabbit was 3 months old, and that one rabbit weighed 6 pounds. Are we happy then that scatter plots are ways that we can use to represent data that is two combined? Would you agree that the age of the rabbit and its weight belong together, right, as a single piece of information? But that single piece of information has got two distinct things, isn't? Even the units are different. Isn't the first number the units are months, but the second number the units are pounds? They're not even the same things, right? But together they tell us something. So we are going to look at these fellas, and they're called scatter plots. That's the name we gifted this thing. And we are going to look at patterns in scatter plots. And not only that, we're going to introduce you to some terms that we use to describe scatter plots. So the first thing we're going to look at is called association. A scatter plot can have one of 3 kinds of association. It can be positive association. It can be negative association, or it can have none, no association. Now let's show you little baby versions of positive associations. If you have a scatter plot like these guys, the one thing that they both share in common is, for want of a better word, aren't they both going uphill? What that means is the X variable gets bigger doesn't the y variable get bigger? Right? That's called positive association. Oh, and do you notice that the scatter plot doesn't need to be like a straight line? Can't it be curved as long as it's going uphill? Now, for the second situation, you might get a scatter plot that looks something like this. And again, what makes these negative is, can you see that they are going downhill? Right, as the x gets bigger, doesn't the y thing become smaller? And when you have that situation, these are called negative association. And then the third one. Well, really, I can only draw one version of none because I can't think of two. Can you imagine a scatter plot where there's no particular anything going on, just a big ball of randomness, nothing, right? That would have no or none association. Are we comfortable with the term positive, negative, and none? Can you visualize what a scatter plot that had positive, negative, or no association? You good? Right. As I say, a lot of notes today. So that is association. Now we're going to do strength. How strong it is. And there are going to be three words that we're going to use. It's going to be strong. We're going to say that it's strong association. We're going to say it's a moderate. Or we're going to say it's a weak association. Show you what those three guys would look like. Let's do a strong association. Would you agree that's positive? Would you also agree that the dots are very close to each other? There's not a lot of variation. Agree? Positive, yes, but it's also a strong association. Suppose it's still positive, but not as close together. Would you agree this is a little bit more spread out than that? Right. And so I'm going to call that moderate. And then weak. I mean, it's still got that, direction thing. It's still positive. Would you agree? But isn't that very weak? It's just going uphill, but there's an awful lot of connection between them. This is not mathematical, but it helps me because I'm a visual person. What I tend to do is I tend to draw what I call sausages. Do you notice that when you've got a strong association, don't you have a long, skinny sausage? And when it's moderate, doesn't the sausage get a bit bigger, fatter? And when it's a weak association, doesn't it almost look like an egg? So, that kind of helps me visualize it. If it's, I kind of draw boundaries around things because it just, for me, my brain works better that way. Does that make sense to you, the naming system, right? An association. Now, can you get a version of going downhill and then curved? Of course you could. Oops, wrong color. Would you agree that that's positive and it's strong? It just happens to be curved. You're allowed to be curved, right? Now, there's going to be a judgment call. What do I mean by that? There's going to be a scatter plot that Christy thinks it's moderate, but Rob thinks it's strong, right? Because could you agree that there's a whole load of grey areas between these extremes? And so let's show you how you get around that problem. Okay. Would most of you agree that's strong? Yeah. If I make it just a little bit fatter, would you agree that it's not quite as fat as moderate, but it's not quite as good as being strong anymore, right? Because if I do the third one, which is the one I'm trying to convince you is moderate, moderate would look quite similar, right? But just a little bit more room to it. So how do you get around that? If you're not 100% sure that it's strong because you think it's not quite strong, but you think it's better than moderate, you're allowed to qualify it by just saying it's moderately strong. So wouldn't moderately strong kind of fit somewhere in here? And moderately weak would fit in here. Does that make a kind of a good compromise when you're not 100% sure? Because it's kind of on the borderline between, yeah, I think it is, and somebody else might think it's not. Wouldn't you probably both agree that it's at least moderately strong if you had to, right? Now, if you get a question and it only gives you the three choices, you're going to have to commit. And you might think it's moderate, and then the thing tells you it's wrong, so you just go back and pick strong, right? That's all you do, if that happens. Are we comfortable with positive, negative, and none? Strong, moderate, and weak? Linear. Oh, I've got to tell you what it is. Shape. Scatter plots can be linear. I don't like this name, but that's the one they use. Curvy, linear, and none. So a shape is said, or a scatter plot is said to be linear if it looks like it's on a straight line. Okay, that's what linear looks like. If the data has a curve to it, don't know how good I'm at drawing curves there. There, I think I did okay here. Would you agree that data looks like it's got a curve to it? Then we call it curvy linear. I much prefer the name curve. I mean, linear and curved. Isn't that easier to understand? The thing's linear, the thing's curved. The word curvilinear is a bit of a distraction to me and misnomer, because doesn't it have the word linear in it? And that's kind of throws me a little bit, right? But, okay. Now, what would the shape that had none to it? Well, would you agree that this one over here has none? It's not linear, it's not curvilinear, it doesn't have any shape, does it? It's just random dots. Now, if you put all of that package together, positive, negative, none, strong, moderate, weak, and linear and curvilinear, you can actually describe a scatter plot using words. So let's start with a brand new scatter plot. And let's talk about describing it. Okay, here's a scatter plot. Positive, negative, or none?
Negative.
Okay, so we would call it negative. I've tried to make it obvious. I hope I have. Strong, moderate, or weak?
Strong.
That's what I was hoping you would say. Linear or curvilinear or nothing?
Curvilinear.
Curvilinear.
Right. So if I gave you this picture, couldn't you use this vocabulary to describe what you're saying? Let's put it the other way around. Imagine I have a scatter plot and I tell you it's positive, it's moderate, and it's linear. You should be able to, not with scales and things, but shouldn't you be able to imagine what the shape of it would look like? Great. It's positive, moderate, and linear. I'd probably focus on the linear first, right? Doesn't linear mean it's a straight line? Is it a straight line going up the way, or is it a straight line coming down the way? You're pointing with your finger, so just say the word, Lauren.
Up.
Up. So would you agree that it is going up? Right? Now, all I need to do now is decide how thick my sausage needs to be to describe moderate. Would you agree right now I'm probably describing a strong one? So if I want to make it moderate, don't I just make my sausage a little bit thicker? Yeah. Does that look moderate to you now? Maybe I overdid the moderate a little bit. But with only 3 words, can't you visualize what the scatter plot would look like? So this vocabulary is helpful in discussing things. Now, haven't finished. We're now going to, oops, new page. We're now going to add a 4th and final term. They're called outliers. Almost any time you collect data, isn't there a chance that some of them are kind of way out there? So what does an outlier look like in a scatter plot? So I'm just going to do a typical linear positive, reasonably strong, whatever you want to call it, there. Would you agree that that scatter plot doesn't have any obvious outliers? There's nothing weird about it, right? Every one of those dots, even the ones at the ends, don't they kind of belong together, right? And to emphasize that, I'm going to draw my little sausage. Isn't that, inside that sausage, isn't that where the data lives? That's where all the usual numbers are. How about this guy? Well, he's an outlier. Right? I made him kind of bigger than the rest. But isn't that point an outlier? What makes him an outlier?
He's nowhere near the grouping at all.
Right. He's nowhere near the right. He's a nice big, you see, it's like a 2-dimensional thing. You just need to be away from the rest of the data. See, when it was just a normal, 1-dimensional thing, didn't you only have to look at the tail ends, right? Left and right. Was there a big gap and then a guy? That would be an outlier. I'll put letters on them. A is an outlier. Is B an outlier? Agreed? Another outlier. This one catches people. C is an outlier. But you might say, wait a minute, if you just imagine that with a straight line through it, isn't C going to be in the same line as the rest of the data, right? My pen's covering it. Agreed? Wouldn't C be in the same line roughly as the rest of the data's pointing? But why is C still counted as an outlier?
Because it's still far away from the database.
Yeah, you see that nice gap there? One of the reasons I like my sausage, it helps me visualize the data, but doesn't it also help you visualize separation? I can see a sausage and I can tell if you're inside the sausage, you're good. If you're outside the sausage, you're an outlier. Now, of course, there is no test for these guys. No obvious test for these guys. And we're not even going to go into, you know, like the interquartile test or the 3 standard deviation test. They do exist, but that's beyond the scope of this course. So we're not going to go there. We're just going to eyeball it. In other words, the kind of questions you're going to get are, here is a scatter plot. Can you find any outliers? Now, when you tell someone where an outlier is here, can we pretend that that number is 70 and this number is 20? So you would say there was an outlier at 70, 20. Do you see that you need to give the coordinates of it? Otherwise, people don't know which guy you're talking about. This guy up here is called B. So can we pretend that that's 25 and 30, 40, 50, 60, 70, and that was 75. So that guy there, right? B would be 25, 75. And that guy over there, I'm just going to pretend I know what the answer is. He's 100, 100. Okay, that'll work for me. So if you have to tell someone specifically who is the outlier, for clarity, don't you have to tell me its coordinates? You can't just say there's an outlier at 70. Because if you say that, you might mean that, but couldn't you also mean any of these guys up here? Because they also have an X coordinate of 70. So you need to tell me both. Any questions so far? We're feeling good. So there are some questions. Well, you'd expect that. There are going to be some questions from the homework. And I'm going to go to them right now. Because some of it is obvious. And especially at the beginning, it's a little bit less obvious. So let's get those guys out of the way first. Is anyone I should know in the chat? Okay, I got it. I'll try and make this bigger, but I think if I make it bigger, some of the writing's going to disappear. Oh, isn't that nice? It actually doubles up writing. Perfect. There. So there's a fighting chance that you'll be able to read this. I don't know what kind of screen you're using. Now, for each of the following pairs of variables, is it likely to be positive association, negative association, or no association? So they're not giving you a picture, they're just describing the two things. The amount of alcohol you consume. So imagine the x-axis says I had 1 drink, 2 drinks, 3 drinks, 4 drinks, 5 drinks, right? The amount of alcohol you consume and your performance on a test of coordination. Okay, so the more you drink, won't you do worse in that test? I would assume. Doesn't that look to me like a negative association? You see what I'm saying? The bigger the alcohol, the worse the test. In a positive association, the bigger the first thing, shouldn't the bigger the answer be, right? Both go up at the same time. In a negative association, the bigger one gets, the less the other. So that should be a negative association. But if you look really carefully, there's 2 guys that mention negative. We've to pick the one that gives the correct reason for negative. So the top one says, we expect it to be negative since we expect the coordinates will decrease when the amount of alcohol is consumed is increased. And that's exactly the right one. So let's look at why the other ones be wrong then. They said it's negative, and then they said the reason for that is that when the first guy gets bigger, the second one gets bigger. And that's not the case, right? So that's this one. How about your height and your GPA. So along the x-axis, you've got you know, a 52-inch student, a 53-inch, right, a 61-inch, a 72-inch, all the way going that way. And up the side, you got the GPA of that student. Now, if you plotted that scatter plot, would you agree that tall people aren't brighter or stupider than short people? Wouldn't that data be just all over the place? And when it's all over the place, what kind of association do you have?
None.
None. Right. The weight of your car and how many miles per gallon you get, right? So you got lots and lots of cars and you measured their weight and then you looked at their miles per gallon. So imagine heavier car. What's going to happen as the car gets heavier to the miles per gallon that that particular car gets?
Negative.
Yeah. Would you agree heavier cars, worse miles per gallon? Typically. There are always exceptions to everything. Do you see that they're just written versions of my pictures, right? Here's another bunch, but I won't go into, you can have fun doing those ones. And here is our first scatter plot. And it's the first one where you actually get to look at some data. And this particular data is percentage people taking a test goes this way, and the average SAT. So every single one of these dots actually represents one state in America. So see this dot here, right at the end? In this state, about 80, whatever the right number, let's pretend it's about 84% of students take the SAT, and the average SAT score they get is about 480. See this dot way up here, this one here? Only about 4% of the people in that state take the SAT, but the average is about over 600, right? So do you understand how to read off all these little dots? Right. So, I mean, they've got their own questions, but I'm going to use mine. Looking at that data, positive or negative association?
Negative.
Yeah, isn't it? I know it's not great, but isn't it going downhill? Roughly. Can you see a downhill path? Right? If I was going to put a name, strong, moderate, or weak, what would you probably put on that one?
I'd say moderate.
The hesitant is because you might want to say weak. So how about calling it moderately weak? If they gave you the choice. But if they didn't give the choice, moderate will do, right? And some of you might say weak. And then we have to figure out what Web of Science says it is. Is there any dots in there that look to you that they could be outliers? Now, remember, to be an outlier, you really have to be noticeably different, right? You don't get by being a little bit different. Does any of them look noticeably different?
The one closest to the 80, all the way on the edge, may be an outlier. I think it is, because there's that line and then it's the dot.
Right. Are you talking about this dot here where my mouse pointer is? I hope you can see my mouse pointer. Right.
Yeah.
Yeah. Some of you might be thinking about that one. Right. These are judgment calls. Me personally, I won't make any of those an outlier. I'm not saying Lauren's wrong for picking what she picked. I'm just saying I wouldn't. For me to be an outlier, the dot would have to be like up here. Do you see where my mouse pointer is way up there in the middle of nowhere? It's got to be that bad to be an outlier. I'm not kicking that one out because I know it's got a definite gap, but you know, in the big scheme of things, it's not a huge gap, is it? Not, in my opinion, anyway. This one's a little bit far away, but not really that much. So maybe most of you probably wouldn't pick that. The next one we could definitely argue about, and I'm going to argue because I know the right answer. I just don't agree with them. Linear or curvilinear?
Curve.
Curvilinear,
Agreed. I agree. Do you know what they think it is?
linear.
Yeah. You know, different people see different things. Did some of you look at that and say, yeah, it's not great, but it's kind of a straight line-ish? In which case you would be in their side. Me, I see more of a curve than I see a line. right? Do you know, what's the word I'm looking for? Objectivity is very difficult here, isn't it, when you visualize things? One of the problems with the human brain is, don't we look for patterns even when there's not one there? Most people, if you look at clouds hard enough, can't some clouds look like faces or animals or something? You know they're not there, right? You know there's not faces in the clouds, right? It's just your brain tries to interpret things, and so that bump becomes a nose, right? And that other darker bit looks like an eye. Isn't that why when you look at the moon, you sometimes see the man in the moon? You ever notice the face on the moon when it's a full moon? There isn't a face on the moon, right? There's just some craters that your brain has decided look like eyes, or at least are together, and that's where eyes should be. So we have to be really careful. Our brain is so good, it's hardwired at looking for patterns, which means sometimes it sees patterns that aren't really there. But it fills in the gaps intuitively. So your brain is really dangerous. We later on will discover that there's a number that you can calculate. And that number, it's called the correlation coefficient, will tell you how linear your data is. And it's a number between -1 and 1. An R value of 1 means it's a perfect straight line. But a 0.9 is pretty good. It's still a straight line, right? Things like that. Which is very good, because human eyes and brains aren't good at deciding. Now, they ask some specific questions. Now, if I went and said to you, what is the highest percentage, well, not what state, but what's the highest percentage of test takers? Would be that dot there, agreed? And if I said, what percentage is that? Well, that's 80, that's 90. So I'd be guesstimating that's about, what, 84-ish? If you click on the data, can you see that it tells you what the data is, and you just can read through it and you find it? So it's actually 83. Right, I said 84. Do you see I was close, but not perfect? And what was the SAT score that they got? 476. Now, what's the highest average SAT? Would you agree it's that top one, that dot right there? The biggest average SAT is the highest up. If I click on the picture, can you see what the highest ever achieved SAT is? It's in that list of numbers. What's the biggest SAT score?
.601.
Yeah, you see it down there? You could argue, I guess, it's 605, but they've just rounded off the numbers. That specific value, 601. That's it. All right, here's another data set. I'll take a volunteer. I want 4 things out of you. I was going to say 3, but I changed it to 4. In any order you like. Positive, negative, right? I want you to tell me that. Curvilinear, linear, I want you to tell me that. Strong, moderate, weak, I want you to tell me that. And does it have outliers, right? So I want the whole set. Who feels comfortable about saying it all?
I'll give it a shot.
Go for it, Rob.
I'm gonna say it's a strong, positive, linear with no outliers.
I'm only going to disagree with one of those. Which one do you think I'm going to disagree with?
Outlier?
No, it has no outliers. I would agree with that.
Oh, yeah.
Only one of those terms I would disagree with.
You're gonna call that moderate.
Yeah.
Yeah.
Or even moderately weak, you know.
Yeah.
If you think of the sausage, isn't that a big fat sausage?
Okay, yeah.
Right? Think sausages. Skinny sausage, strong. Moderate, big fat sausage.
You know, you're ruining breakfast for me.
I'm doing what? Sorry?
Ruining breakfast for me.
Oh, sorry. Curvilinear is a banana, right? If you want visuals. Maybe that'll make your breakfast better, right? And they go in and they talk about linear and curvilinear and all that good stuff. So I'll let that one hang for you. Right, I'm going to have to shrink this up a little bit. Here is a question where the data is given to you as a table. So let's explain the data before we do the scatter plot. Here are various cities in America, obviously not all of them. And we are going to compare latitude, which is basically how far north or south you are. You know, longitude goes this way and latitude goes that way, right? And the latitude of it and the average August temperature. So our scatter plot is only going to use the latitude column and the August column. Knowing what the city is interesting, but that doesn't appear in the scatter plot, and we're going to ignore the January for this one. Now, can you imagine you could set up an X and Y axis and plot those? But wouldn't it be nice if Salt did it for us? So let me show you how you can get a scatter plot for latitude and August temperature. So click on Use Salt. I shouldn't have done that. I should not have done that. Give me a few seconds. I don't know why it does that, but it does it because it can. Okay. I'll do it again. Now we're good. There. When you hit Salt, that's what appears. Now I'm going to go up here and I want a scatter plot. So I'm going to pick charts and graphs. And then I'm going to go here and I'm going to do scatter plot. And it looks like there's something wrong. Well, it's not that there's something wrong. I just haven't told it enough information. So the x-axis is going to be latitude and the y-axis is going to be the August temperatures. Can you see I can now, there's my scatter plot. Maybe I shrink it a little bit more. There we go. Can you see my scatter plot? Already done. Now, if you were describing this scatter plot, would you agree that it is negative association? I don't know if you agree, I hope you will. We agree it's linear. Now, you see that dot there might make some of you think more curved, but pretend that wasn't there. Isn't the rest of it very linear? Do the sausage thing. Moderate, weak, or strong? What would you look at that as?
Moderately weak.
Yeah, definitely. If I hear moderate, I would be fine. If I heard weak, it'd be fine. If you want to cover yourself, as Lauren just did, pick the one in between them, right? That seemed reasonable, moderately weak. Some of you might have went more on the moderate side, some of you on the weak side. This one here is now to be finished with, do we have some outliers? I think we do. If we did, where do you think they are?
38, 64.
Right. See the mouse? You see the little green mouse thing I've got, that guy there? Does he look like he's far enough from the rest of the sausage? Right. Yes, I would say that's probably an outlier. Is there any other guys in that list that might qualify? We're not saying for sure he's an outlier, we're just saying he's a candidate.
33, 92.
96.
Right, I see a 3392, so some of you are talking about that dot up there. Would that seem like it could be a candidate? And there's one more that I keep missing, and I think someone said it. Isn't there one right next to the right, and that's away over here, that might be one as well, might not be. So when you're doing a scatter plot, you might want to say, you know, there's a candidate for a for an outlier, right? Occasionally, it's so obvious, I'll say it's an outlier. But can you imagine sometimes you might say, nah, I don't think that's an outlier, and other people might think it is.
Professor,
Robert, yes.
would you count 4764? It's right by the word latitude. Would that one be an outlier in your opinion?
In my opinion, no. And the only reason I'm not is, I'm back to my sausage thing. I think that guy just makes it inside the sausage. I think the sausage is going roughly here. And that's the last one in this. You know, there's always going to be somebody at the end, right? And I think that one is close enough to the others. Because they are pretty spread out, aren't they? All the dots are a little bit far away from all the other dots. You know, a little bit at least. I think, in my opinion, that one is okay. I would keep that one, in my opinion. But don't quote me on that, because you know, I used to be perfect, but I'll get that the other way around. I used to be conceited, but now I'm perfect. Right? That's a joke. God, this is going to be a long week.
Again,
Gotta get this joke out of my head. This is a different joke. One of my Calc 2 students went and told me this one, so I feel kind of obliged to share it. There we go. He went and said, I sent a letter 4 years ago and it still hasn't arrived. And then I found out why. You might say, why?
Why?
I wrote it on stationery. Robert, is that joke that bad that it's good, or is it just that
yeah,
bad?
it's almost so bad it's good. That's the correct definition.
Lauren, you're killing yourself, so you obviously think that's funny. Robert, the other Robert this time, Robert Collar. What do you think, Robert? Just bad?
I know if I tell that to my girlfriend, she's gonna love it. It's a groaner to me.
Oh, I love grown-ups. Okay. Now, I forgot where we were. God, I'm so easy to distract myself. Have you noticed that? But anyway, let's keep going. That guy that we just did, right? This one here. One of these 4 pictures represented that guy. I know that this is a smaller version of that, but if you recollect it, didn't that guy there look like it, the first one? So once you've done your scar plot, you go and look at the 4 choices, and whichever one of them is closest is the right one. And then you talk about linear and patterns and so on. Here's question 6, which is basically the same thing, right? And, you know, do salt and do the pictures and so on. What's this one about? Oh, this one is quite realistic. If any of you ever go into real estate, you know, sell houses as a business, right? Or buy houses for other people, whatever you want to call it. One of the things that you have to figure out is someone comes up and says, well, I want to sell my house. And you have to try and come up with a price, right? And you might think, how do they come up with the price of a house? I mean, they could just look at, well, what did next door sell for? That's a very good way of doing it. But, you know, maybe next door was a dump, right? And it didn't get as much money as yours because yours was quite nice. So what they tend to do is they collect data on square footage and prices. So that 453 actually means that that was being sold for 453,000. So we're going to use salt on this and see what the scatter plot looks like. And remember how we did that? You hit charts and graphs, you go scatter plot, and the x-axis is going to be the square footage, and the y-axis is going to be the asking price. And there's the data. Now, there are not an awful lot of data points here, so you have to be quite generous about it. But do you see that the data is definitely at least going upwards? Not very clearly, but it looks to me like it's going upwards, which kind of makes sense. Isn't a house with more square footage likely to sell for one that's got less? If everything else is the same, right? It's in the same street, got the same view, right? So bigger houses, bigger amount. Would you also agree that that guy right at the end is an outlier? So if you were doing comparable house prices, right, you probably shouldn't use that in your data set. Outliers are like Bill Gates. They screw up everything, right? Don't use them. So I'm going to try and go back to the original data. And oh, that's not the original data. I'll have killed it if I got time. I do have time. I'm going to get that one because I want to do it. I'm going to kill the outlier and look at what the scatter plot looks like without it. Okay. So where is that guy hiding? Okay, so the guy that's causing trouble there is, can you see it's that guy there, 1.5, over 1.5 million, right? Everybody else is what, 1 million less than that. Can you see that's a distortion? So I'm going to go use salt again, and I'm going to go down and I'm going to take this guy and edit him. And I'm going to edit him by killing them. Do you see that guy has now left the building? Right, I've taken it off my data set. And so when I now go and do my scatter plot, and I do square footage, and now I do asking price, do you see that it found? Is that still there? No. Oh, I thought I'd taken care of that one.
I think you have to hit the delete button next to the edit button.
Oh, shooting space. Okay, I don't have time for this because I just looked, we're pretty much finished. Can you trust me if I get rid of that guy correctly? The scatter plot that was left would look much more linear and much more easier to predict. Because what the guy could then do is say, oh, your house is about 2,500 square foot. 600,000 is a pretty good number for your area. And that would be at least a price. And then, people look at it, and if they like it, they'll bid more because there might be a bidding war going on. If you overdo it, won't people put in an offer that's less, and you might still accept it. But at least there's a number there, to start the ball rolling, right? How much you want for your house? Well, I want 600,000. And you're going to say, nah, it's worth 550. And then you argue about it, right? That kind of thing. Helpful? Scatter plots? Good. Outliers? Bad, right? Screw up the picture, make it hard for everybody, including me, to make them go away. So remind me on Friday, I'll have another shot at that one, okay?